Hi, it's me, Jazzy. I'm back with another tech-related video, and today I'm taking a look at an amplifier. This is a Carlsbro Powerline 300, and it's one of my spare disco amps. And the main reason I haven't been using it is because of a horrendously noisy fan. So we're going to take a look at that today. We're going to replace the fan, give the amp a good check over. I think the pots were a little bit crackly, so we'll take care of that, and then we'll put it on the scope, have a look at it, and maybe do a load test as well, just to make sure it's all working as it should be. So we might be able to tell what the Powerline 300 actually puts out. Let's get it over on the bench and take a look. Right, so this is one of my backup amplifiers. This is a pretty simple beast. Carlsbro Powerline 300 watt amp. It's been okay. It's not one that I use often, and the reason I haven't been using it lately is because this fan is horrendously noisy. You saw it in one of the thermal camera reviews that I did. I was using this amp, and this fan is really noisy, so it's got to come out and be replaced. And while we've got it on the bench, we may as well just give it a check over, check the caps, give the pots a clean and stuff, just make sure the output's okay. Then it will go back into being a standby amplifier. I don't do so many mobile discos now. The stage line one that I repaired last time is the main one that I tend to use when I do. And whilst these Carlsbro amps were never the best, they were built down to a price. They were rather good value. They're very cost effective, and yeah, it will do the job. So the first thing I'm going to do is work on the fan, because when I'm testing this for output in a minute, I don't want to be listening to this fan. It's horrendous. Let me just plug it in so I can give you a before and after. Switch on. Yeah, it's like a jet aircraft taking off. Nice. That's enough of that. Apart from that, it actually works alright, so it's just a quick repair today, really. And I reckon if I can get the back panel off, I can get this fan out without having to mess around with anything I don't need to. To be fair, this amp's been alright. There's nothing actually wrong with it, and as they say, if it ain't broke, don't fix it. But while I've got it on the bench, I might as well give it a once over. Right, this should, here we go, just pull off now, which means hopefully I can now access this fan. Oh yeah, there we go, that's fine. That gives me enough room to get in there. Yeah, this fan's pretty old. This has seen better days. We're going to replace it with a newer equivalent 12 volt DC brushless fan. So we're going to replace this noisy one with this, and then we're going to, while we've got it apart, we're going to give the pots a good clean, give it a check over, have a look at it on the scope. Other than that, we're just going to remove the dust, give it a good clean up and put it back together, and this can go back into service. This is only a spare amp. As I say, I don't use this one very much. It's not particularly powerful, but it's an okay amp, and it's good to have a backup. So let's get this old crusty fan out. So this amp claims that it's 300 watts, which I very much doubt. I think that's likely to be some exaggerated peak output claim. I'm not sure what the RMS output of this is. What we might do actually, once we've checked this over and given it a bit of a service, I think we might do a bit of a load test on it, because I don't think I've ever done that on this amplifier. I've not used this one in ages, hence the dust. It's been in storage for a while. But I figure it's a good time to give it a quick check over. It's always a good idea to carry a backup amplifier, because as they say, the show must go on. So regardless of whether you've had any technical problems, you need to be playing music. To use the double screwdriver system on this one, otherwise the screws that hold on the fan grill just spin round endlessly and you get nowhere fast. This is most likely why I've put up with the noisy fan for so long, partly because I very rarely use this amp, and partly because it's a bit of a faff getting these fans out. One more to go, and we can release the noisy fan. It literally sounds like a small aircraft when you start up this amplifier. I mean, it's an okay amp. It's pretty basic. You got a relay there, protect your speakers, so you don't get a thud through your speakers when you switch your amp on. Right, so we got the grill off the back. It just needs a little bit of a clean. Other than that, it's fine. This fan is noisy and dirty. Pretty fairly old. It's a Sanyo Denki Co Limited, made in Japan. I got a feeling this amp was secondhand when I got it. I can't remember now, but I don't know how many hours use it's got on it. What I'm going to do is I'm going to rob the connector off of this, because the replacement that I've got here has a Molex connector on it. So what I'm going to do is I'm just going to rob the connector off of here and solder it onto that one. Let's just move that cable tie. Make life a bit easier for myself. There we go. Let's put another one on afterwards. Now we can see where this is going. So rather than mess about, I'm going to snip this off. This is the old fan. This is a new one. Brushless fan. 12 volt. 0.25 amps, that's the 0.26. It's comparable, it's just a newer fan, but I've got these in stock, so I'm just going to use what I've got in stock. What we do when we load test it, I'll put the thermal camera on it and check the temperatures to make sure this is putting out enough airflow, but I'm sure it'll be absolutely fine. You've got a lot more blade space, and the blades are a more modern design. I'm sure it'll be a darn sight quieter than this one anyway. So that one is out. So what we need to do before we put anything into this is we need to get rid of some of this dust, because it's horrendous. Get the worst of the dust out with this brush. You do tend to get dust balls in amplifiers that are used in nightclubs, because you get the residue off the smoke fluid from the smoke machines and stuff, and the dust sort of congeals into little dust balls. I just feel better about putting something together that's clean. I'm happy with that. That looks a bit cleaner than it did. We've got to make sure we get the flow of the fan the right way, because we don't want to be blowing air into the amp, we want to be blowing it out. This is the exhaust fan. Right, this fan's got a Molex connector on it, which I'm going to cut off. It's just that I've got a few of these fans in stock, so I might as well use what I've got. One thing I always like to check before I commit to putting the fan in is, does it actually work? I've got it hooked up to my power supply, set to 12 volts. That's a nice breeze and a really quiet fan. Fantastic. Fantastic. Let's get this in then. Alright, let's solder it first to the connector that I've got. We'll just solder it and do a bit of heat shrink. Now, I know what you're going to say. I should have a stock of these little connectors, but I have not at the moment. This is just an ad hoc little job that I decided I was going to do while I had this amplifier kicking about. Right, let's see if I've got some little heat shrink. Will that go in there? Yeah, that's good. Very helpfully on this fan, did amuse me slightly, by the way, bit of a diversion. You've got two wires there. We know which one the negative and positive is, but it does say on here rather helpfully, red plus, green minus. They negated to put red and green cable on it. That's quite entertaining. The original one did. The original one was red and green. Well, that green's a bit discoloured now. Alright, now I'm going to need to tin these first. Now, again, joining wires like this, there's a school of thought that says you should twist the wires together. And there's a school of thought that says don't twist the wires together. In this instance, I'm going to not twist the wires together. Would help if I didn't have the shakes today as well. Okay, that's fine, fine, fine. Now we know which way it's going. It's blowing the air out this side, so that's the way we want to have it in. Right, that's better. Ooh, are the little standoffs going to fit? Slight modification here. Right, let's have a try. Right, I think we've got just about, yeah, we can make that work. Yeah, that'll work nice. So we've got our nice clean chrome grille. That's good. Now, normally I'd go ahead and pull this board and check the caps, but it would be a bit of a pain in the neck to try and get this board out. One of these screws has got stripped heads. These look okay. None of them look bulged or anything. And there has been no problems with this amplifier, so I'm not going to do anything with that other than plug my fan in. I think from what I remember, it's had crackly pots. So while we've got this apart, these kind of amps were built down to a price. I've got another amp I'm working on at the moment, a MOSFET amp, and it's an Ad Astra PA amp, and it clearly is designed to be easily serviceable. Okay, it's quite convenient. I'll go with that. Give it a bit of an exercise. You don't tend to use these that much. I mean, generally once you've set it for your event or your gig or whatever, they don't tend to get adjusted. There's always that one occasion. Now, where's the... oh yeah, I can just about see it. Goodness me. I mean, it's okay, it does the job. I've got no complaints about this amp, it does a fair enough job. If there was a fault on this board, I would have to get this board out, but at the moment I'm just not going to persist because I don't believe it needs it. I don't really tend to buy new amplifiers for disco use. I generally tend to buy second-hand ones because they're nicely run in then, and they're a lot cheaper. What I am going to do before I commit to screwing this panel in is I am going to test this. Of course, what I should have done is shortened that cable a little bit more. Sometimes I'm so busy talking away to the camera that I forget things like that, but it's okay, it'll do. Let's switch on and see how it sounds. Okay. Well, it's putting out a nice breeze. That's certainly a lot quieter than that last fan. And what we're going to do is we're going to test the thermals in a minute, because we're going to load test this and we can see if the fan is doing its job by keeping an eye on temperatures. So that's fair enough. Let's get that back panel screwed back on. What we can do is we can put this on the scope, have a look at the output, and then we'll load it up, put a dummy load on it. So let's just screw this back panel back in. That is the one downside with buying second-hand amps. They're likely to have been serviced or taken apart previously, sometimes multiple times. The other amp I'm working on at the moment, which is more of a long-term project in the background, is the Ad Astra MOSFET amp. I think I put a picture of it up a while ago. It's got some really bad heat damage on the board. Had to get a lot of new bits for it. So it's looking cleaner. We've got a nice new fan, which is very effective and much quieter. Well, the amp was in working condition when I started, so this is just about giving it a little bit of TLC, so it's ready for use if I need it. What we can do now is put a signal in it and we'll put it on the scope, see what we get, and we'll give it a bit of a load test, make sure I'm happy with it, make sure the thermals are okay with the different fan, and then I can put the lid back on and that can be ready for action when I need it. Right, so I'm all set up. I've got my signal generator going into the inputs of my amplifier, left and right channels. I've got a 1 kilohertz test tone going in. Then I've got my scope probe connected to the other channel of my oscilloscope, and I've got my scope earth, which is the green wire there, going to the earth of the chassis of the amp. So that's the input signal there, the top one. That's the 1 kilohertz test tone. That's coming from my signal generator, which in this case is the multi-comp signal generator that I'm using. That's putting out 1 kilohertz at 1 volt. Okay, so I'm going to touch my scope probe on the output, which is for the left channel in this case. There we go, you can see the output. And if I turn the volume up, oh, that's not bad. Pot doesn't seem to be crackly anymore. Okay, let's try the right channel. Turn the volume up. Much the same as the left, really. It looks fairly decent. I mean, it's not the best quality amplifier, this, but it's all right. And no crackles on the pot by the look of it. Okay, so that's about as much as I can turn it up without the peak light coming on. So what's that? 10, 20, 30, 40. So it's on 1 volt per division. Well, 10 volts per division because it's on times 10. So 10, 20, 30, 40 and a bit. So ballpark 44 volts peak to peak. So we should be able to calculate from that what the output will be. Okay, so we've tested it on the scope. Now we're set up for load testing. So bit more involved setup here. So I've got signal generator going into my amp with a 1 kilohertz test tone. Output from the amp I've got going to my dummy load. This is a new one which I've recently acquired. You'll see it on an upcoming mailbag, I expect. I don't think that mailbag's gone out yet. It's a really cool item. I've given it a clean up and I've given it a test. So we've got the output from the amp going to both sides of the rheostat. So we've got left channel going to one side, right channel going to the other, grounds are going to the wiper in the middle. Scope earth going to there, scope probes on there for channels 1 and 2. So we can see what we're doing. So the one to watch at the moment is going to be the top one because I'm going to test channel 1 first. So as I turn the volume up, you will see, there we go, until it triggers. There we go. Okay. So I'm going to go until the peak light comes on, until it clips. There you go, just there, look. That's it. Now, I don't know if you can hear it on my mic. The rheostat is actually singing. I don't know if you can hear that on my mic. We'll find out. Maybe I can boost it in post. So that's your left channel anyway. That's running quite nicely. Let's have a look at thermals. Right, you can see my heatsink is working away there. You can see that's doing its job. Alright, we've got one power transistor down there that's getting a bit warm. Because don't forget, we're only on one channel. So that's why we're only seeing one area of heat. That one's not doing anything. So, let's swap over. So, alright, so let's have a look at channel 2 then. Let's crank it up. Alright, again we'll go till it clips. There. Alright, so let's... Okay, so 1, 2, 3, 4, 4.5 times 10, 45. So same there, 45 volts peak to peak. And now we're on this side. You can hear this side is singing. You can actually hear the rheostat is making a high-pitched noise. This is normal, don't worry. Nothing bad. So you can look at the rheostat. Wow, yeah, you can see where that one is hot. This one is just heating up. This is the one we're on at the moment. That one's still cooling down because we did run it for a bit. You can see actually my soldering iron is still hot because I've been doing some soldering. I've been doing a bit of everything today. So now let's try with both on load. So again, we're going to go up to just where it peaks. That's very comparable there, so I'm very happy with that. So the performance of the amp is looking pretty good. So thermals now, we are really pushing it now. There you go, you can see where that's getting hot there. Heatsink is doing its thing. We're looking alright down there. The transformer's starting to warm up a little bit, it's not bad. So both channels are just below their peak, and the fact that the volume knobs are in a similar position. Now in terms of the rheostat, that's heating up lovely, look at that. I'm pretty happy with the thermals. See, in this case it's really handy having a thermal camera, because you get that real visual indication look of what on earth's happening inside your device on test. You can see what's getting hot, what's not. Absolutely would recommend having a thermal camera in your arsenal of tools for fault finding, even if it's not one quite like this. This one is excellent, but it's just really handy to have that visual indication of what on earth's going on. And I can see with my rheostat over here, this is the first time I've actually put a decent load into this rheostat. I've not had it long, it's only arrived here a short while ago. That's why you've not seen it yet. It'll be on the next mailbag, I think, when I open it. Sometimes videos do run out of sequence slightly. Now you can see the part of the rheostat that we're using there, and the reason for that is we need a 4 ohms load for this amplifier. This amplifier would be running 4 ohm speakers, so I had to set this at 4 ohms per channel. This rheostat is capable of 12 ohms in total, 10 amps. It's quite a decent rheostat, this one. I bought this specifically for load testing amplifiers, and it's gone straight to work on this Carlsbro Powerline 300 here. So I'm quite happy with this. This is sat rock solid while I've had it on test. The new fan is nowhere near as noisy as the old one, and it's clearly doing its job because the thermals are okay. Obviously I don't have the lid on it yet, and I'm sure we're going to be absolutely fine. Right, so we're going to do the same thing now, but we're going to do it with both channels. I've got this now on 20 volts per division on both, so we're going to really push this to the max before it distorts, and you'll hear this really sing. So we're going to go same again to where it distorts and then back it off, same on the other channel. I'm going to need to back that off slightly, that one slightly off. 20, 40, 60, 80 roughly, 20, 40, 60, 80. Right, let's turn that down. I don't want to leave that up for too long because I don't want to damage my amp. Okay, maths time. So it managed 80 volts peak to peak. So we need to divide the peak by 2.8 to get the RMS value. Somewhere on here, watts equals volts squared divided by ohms. So 80 volts peak to peak divided by 2.828 will give us the RMS voltage of 28.288, or call it 28.29. So the formula to calculate that then is V squared over R, which is volts times volts divided by 4 ohms. And that comes out to just over 200 watts. Now, that's a surprise. Would you believe a budget amp that actually exceeds its spec? That's a lot more than I was expecting. Now, obviously, these amps are not designed to have a continuous sine wave put through them at full tilt like that. These are designed, obviously, to have music going through them. So I'd say with the music average being lower than a constant sine wave, you're going to be fine putting out 200 watts RMS to your speakers. That's pretty good. That's actually is a lot more than I expected to get from that amp. Like, obviously, if you're going to be running at that sort of level, your peak light is going to be on. I don't tend to drive this amp particularly hard for most of the little gigs that I do, so this is more than enough for what I need. So there we go. That's my Carlsbro Powerline 300 amp, back in fully working order and tested, ready for use when I need it. So I hope you've enjoyed today's video, taking a look at this Carlsbro amp, and as always, many thanks to everyone for watching, sharing, liking and subscribing. If you do want to go ahead and hit the subscribe button, it's always massively appreciated and helps to support the channel. I'll be back soon with some more tech related videos, but in the meantime, take care and I'll see you on the next one.